I would say the systems integration stage is where we actually turn the project into reality. And we start finding all the little minute problems that don't show up when you're just looking at it on a piece of paper.
A vendor put too thick of a paint coating on something, or, machine parts are out of spec. You can design the perfect part, and then when it gets made, all sorts of things happen, all sorts of non-idealities, and the integration stage is where you take those non-idealities and you have to rapidly basically solve those problems and make sure you can still meet the deadline.
And so part of our process and our specialty is addressing those bugs and those defects that come up, and very quickly and efficiently correcting whatever needs to be fixed to make sure that the solution works as expected.
Recently, we developed an electric amphibious vehicle. What was unique about this project was the open-ended nature of the brief. So we were able to completely come up with our own design, starting from scratch, from nothing. And we came up with a totally unique vehicle architecture.
We had a lot of teething issues. Wouldn't have enough torque to get started. It would dig itself into the sand, or it wouldn't be able to turn. And there was just a lot of sort of detailed dynamics that really showed up in the real world. And so we figured out how to put some shocks on it in order to damp out some of the movements. We put different algorithms for the motor control in order to get it to be more consistent.
We did the entire systems integration of this complex vehicle all in-house. So assembling the different mechanical systems, getting our different motors and actuators installed, programming and reprogramming several times the vehicle firmware in order to address all the different kind of compatibility issues that came up as we were putting these systems together.
I was making sure that my code, if I sent the right command, that I'd spin the motor one way, speed it up, slow it down, spin the other way. Slowly doing these unit tests of each thing, the land motors, the linear actuators, the lights, the aquatic motors.
Within 5 months, conceptualize, design, fabricate, and test an all-new type of vehicle that will enable the Canadian Armed Forces to move equipment and personnel between Navy ships and unimproved shores. Most recently, we've been completing the prototyping of a vehicle control unit, which is a miniaturized computer that helps control and coordinate communication between a variety of different vehicle subsystems.
With e-bikes, there's a lot of ecosystems where you buy your handle, motor, battery, display, all from the same vendor, and it works together. The problem is that if you try to combine different vendors, you have an issue. I've found myself often designing custom sort of intermediate stages to allow these two systems to be integrated with one another. And we've done this enough times that now we've identified a need in the market for hardware that we can drop in to develop projects quickly using a set of hardware that we've designed and we know is very capable.